Go language programming, chapter 4, unit 7. In this unit, we will cover LIFO and stack of int slices, and create also a stack of strings. So let's start. LIFO stands for last in, first out. Okay, that means it uses the stack data structure. So a stack is basically a container of objects that are inserted and removed according to the last in, first out. So it is a stack is an ordered data structure that follows the FIFO principles. That follows the LIFO, last in, first out. Stacks are most easily implemented in Go language using slices. So you can push an element to the stack with the built-in append function. So as we have already covered the append function in previous chapter, that it allows us to append the elements to the slice. Okay, and we will see the append function using with the stack as well. So you can pop the element from the stack by slicing off the top of the element as well. So in the push down stack, two operations are allowed. You push it and you pop it. Okay, so basically the stack concept is easily understood. Is easily understood if we just imagine that you have stack of plates, and that stack of plates you can just add a new plate on the top, and you can basically remove a plate from the top. Okay, so when you add a new plate, you're pushing down the stack, and when you're removing the plate, you are popping from the stack of plate. So push the item into the stack and pop the item out of the stack. Basically that's the concept. Now, to do this, we will have a non-stuck type receiver because we will be using the methods to demonstrate the stack or first in, last out stack. So it will be easier to understand. So to do that, we will have to use non-struck receiver with the method. Okay, and as we have talked in the previous units, that if you have a non-struck receiver, then that receiver or the struck receiver should be in the same package as the method definition would be in. Okay, so that's the key part to remember. Otherwise, the compiler is going to generate an error. So let's look at this example 4-17 and start with the package main and import a FMT package, and then we create a non-struct type definition, which we created for a slice of int. Okay, so that's what we are creating. This is a non-struct type. So basically, stack is an alias for this slice, okay, of int. Now, hopefully, you guys remember that the slices are created this syntax is that you do not put the length between the square bracket. Okay, so if you don't have the length between the square bracket, then that means you are creating a slice. Okay, so basically in this case, once right now we are just creating a definition or aliasing the slice, but whenever it is going to be used, right at line number 17, that means it will create a nil slice, nil slice of stack. So S will be nil. So that means it will have a descriptor like we have discussed previously, but it would not allocate any underlying array. So how does these methods are written? So in here, line number 6, we have a method called empty, okay, which returns the Boolean type, and it takes a receiver, okay, which is a non-struct type receiver that it is taking, and that receiver is passed by value, okay, and then it is returning or it is going to return either true or false. If the length is equal to 0, then it will return true. Otherwise, it will return false. Okay, and then at line 7, we are having a peek method. Peek method is also returning some value, int type. Okay, so it is going to return the index of a slice. Okay, so it will say length, whatever the length of the slice is, -1. So if the length of the slice is 3, then -1 will be 2. So it will be returning the second index, from the slice, or the second whatever the data is at the second index of the slice. And push method, which is taking the parameter of type int and is passed by value, and it is taking the receiver as a pointer type. Okay, but within the body of the push, we are using an append function. Now, in this case, when we are appending, and what we want to append, if it is the data, or we are going we're going to append the data more than the underlying array, then it will allocate, this append function will allocate another array. Okay, it's not going to use the same array like we have talked about it before. Okay, so we will have a new array created, a new underlying array created, if we append too many items in the slice. And then we have a pop function right here. Pop function is returning int type, and it is also taking the pointer to a receiver. Okay, this is a pointer to a receiver. Within the body of the pop function, what we are doing is taking the length of the slice and subtracting it and getting the contents of that location and giving it to this D. Okay, and then that's the data that will be returned. And then here at line number 12, we are saying that from the slice, first element of the zeroth element, go till the length of the actual slice -1. Okay, so that's what we're going to pick up from that slice. So that will be popped from the slice, whatever is at that element is. So within the main, at line number 17, what we are doing is creating a nil slice, very first thing, because stack is an alias of this that at line number 4 that we created. So here we are creating a nil slice, and then at 9 we just print out this string push item. So in this for loop, we're going to be pushing, we're calling the push function, okay, or a push method using this the variable of type this basically non-struct type. Okay, and in this case we will have the s dot push. That means we're going to be pushing this data to the slice. Okay, so we are passing the parameter right here, and then we are using the pointer in the receiver. So the one big reason that we are using a pointer in the receiver is because if append allocates the new array, we will get the the data will be copied, of course, within the body of this push, and we will get the new array when we come out, back to the this uh, uh, caller, which is main. Okay, so the length might be much bigger than what. So if we initially, the slice is up, if it is slice is only 4 elements long, so underline might be, the capacity might be only 4, and if if you're going 10 times, then it's not going to fit. So append function will have to create underline array, bigger array, so then it will copy whatever it has in the original array into the new underline array, and then when the call comes back to it, it actually will have the new underline array because of this pointer receiver. Okay, and we already have talked about all that in the last chapter number 3, about the slices. And then at line number 25, we just print out this. And then here at line number 26, we are basically checking if the slice is not empty. Okay, then we want to go inside the loop and then pop each element from the slice, and the data will be saved into this variable I. Okay, and it is of type int, so the I will be of type int because of this short declaration. Okay, so it will print this the length of the slice, and it will print this the data. And then in line number 32, all we are doing is creating a new slice, a totally new slice. And in this case, my slice is going to be a nil slice. Okay, and when I'm using this append function, it is basically going to create an underlying array, and with 4 elements, and your slice will have 4 elements. Okay, and your capacity in your descriptor. Remember the descriptor when we talked about the slices? It has three items in there. One is a pointer, so it will be pointing to the underlying array, and then the length, and then the capacity. So length and the capacity both will be 4. Okay, so basically, in this case, it will print out this. So let's see the output in the next page. So capacities and the length is 4, and the value is this. That was initialized, and then this is the output from the push and pop function. Okay, so that's how you can use the receiver especially within the push function. So if there is a need for it, and the append function adds or creates a new underlying array, then all that is done properly within the body of the push function. But new underlying array is the one which may become bigger than the original array, and it will be seen by the caller, which is in our case is a main function basically. Okay, so let's look at another example, which is relates to the stack of strings. So in this case, create a stack of strings using a slice. Again, we are using a slice. So we have a non-struct type that we want to create. So we have a stack, which is an alias of this slice of a string. Okay, and then we create a function. This is empty function. In this case, we are checking if it is, if the length of the slice is 0, then return true. Okay, so it will return true, and in this case also the receiver is taking a pointer type parameter. Okay, the receiver is taking a pointer type, or the receiver itself is a pointer type. And then we have a push method. So push method is taking a one parameter of type string, and then it has pointer type receiver. And in here, in this push method, we are using again an append function, just like in the previous example. Okay, so it will append the data to the underlying array. Okay, and create a slice. And we have a pop function. So pop function will allow us to remove the items from the underlying array. Okay, and basically this pop function is also taking the pointer type receiver, and it is also returning two values. One is a string, and another one is a bool. So right here within the pop function or the pop method, very first thing we do is to check if the slice is empty. If it is empty, then we are just returning. If it is empty, then we are going to be returning is false, and I mean the pop will be false. It would not be able to pop it, because there is nothing on the in the slice. Slice is empty. So if it is empty, and then the data will be basically returned as nothing. So if it has something in the slice, then we are taking the length -1. So we are actually getting the actual index of in the slice. Okay, and then we use that index to read the actual data from the slice, and we put it into this element variable. Okay, so index into the slice and obtain the element. So that's what this line number 22 will do. And then remove it from the stack by slicing it off. So this line 23 will remove it from the stack. Okay, and then this basically it returns whatever the element that you removed, and then it will return true. Okay, so in the main, we are calling the push function, so or the push method. So push method is taking string type. So this string Golang will be pushed onto the stack. Okay, so Golang will be pushed onto the stack, meaning put onto the slice, and basically we are calling the push function or push method again with this string width, and then again, so there will be a three elements in the slice, the or three strings in the slice. So basically then we are using the for loop to go uh, through the slice. As long as it is greater than the length of the slice is greater than 0, we want to keep popping. So we pop. Now when we are popping, the pop function returns two values. One is a bool, other one is a string. So this x will hold the string, and y is a boolean, so it will hold either true or false. Okay, so if it is true, that means there was something in there, so it will print. Okay, if it would be false, then it is not going to come into this if statement, and then it will go to the next one. So basically that's how this string popping um, uh, 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 code works from the stack. How you pop the strings or slice of strings, that the slice will have the string type data, and you pop or push on it. Okay, and basically that's about it for this chapter for unit 7, and we will move on to the next chapter. Okay, so